Alright guys, so today we're going to talk about solving quadratics using the quadratic formula. So far we've talked about solving quadratics using factoring, completing the square, and square roots. Our last and final method is going to be using the quadratic formula, which I know many of you guys are used to seeing or doing. If not, that's okay. We're going to work it out today. So the quadratic formula is used to find the solution or solutions of a quadratic equation in standard form. Okay, so our quadratic formula is negative b over 2a plus the square root of b squared minus 4ac divided by 2a, and negative b over 2a minus the square root of b squared minus 4ac over 2a. I like to write it as two separate equations because that really hits home that there are two solutions and not just one. However, many of you guys are probably used to seeing it with the plus or minus. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Either way is fine. So the quadratic formula can always be used to solve a quadratic equation. Alright, so for time's sake, we're going to look at this quadratic equation right here, and we're going to solve using the quadratic formula, and then we're going to graph it. And hopefully from looking at this graph, we can see where some of the quadratic equation gives us some information straight up about the graph. So first of all, this needs to be in standard form, so I am going to rewrite it in standard form, and I'll have negative x squared minus 3x plus 10 is equal to 0. Now I know that my a value is negative 1, my b value is negative 3, and my c value is 10. So now I can apply the quadratic formula. So I'll have x is equal to opposite our b value plus or minus the square root of b squared. So negative 3 squared is going to be 9 minus 4 times our a value times our c value all over 2 times our a value. Alright, so now it's a matter of simplifying. So 3 plus or minus the square root of 9 minus negative 1 times 10 is negative 10 times 4 is negative 40 all over negative 2. So I'll have 3 plus or minus the square root of 49 all over negative 2. The square root of 49 is 7, so 3 plus or minus 7 over negative 2. 3 plus 7 is 10, divided by negative 2 is negative 5, and 3 minus 7 is negative 4, divided by negative 2 is 2. So our x-intercepts are negative 5, 1, 2, 3, 4, 5, and 2. Good deal. I know that my y-intercept is given by my c value, so it looks like it's 10. Alright, then I know my axis of symmetry is right in the middle between these two guys. So that appears to be where? It appears to be at negative 1/2. Alright, so I know I can use symmetry, so I know since there's a point here that appears to be 1.5 away, I'll have 1.5 away over here. And now I just need to find my vertex. So another way to find your axis of symmetry, guys, if you remember from Math 1, is your axis of symmetry is equal to negative b over 2a, which means we will have 3 over 2 times negative 1, which is negative 3/2. So we do have the correct axis of symmetry, and to find the vertex, all we need is the y value. So I'm going to substitute this negative 3/2 into our equation to see what we get. So we'll have negative times a negative 3/2 squared minus 3 times 3 negative 3/2 plus 10. I'm going to simplify this out. We'll get 9/4, negative 9/4, Here we've got negative 9 over 2, and then a minus that, so it's going to be plus 9 over 2. And we've got a 10. So I'm going to get my common denominators. I know I'm running out of room here, guys, right? So I'll have negative 9 over 4 plus 18 over 4 plus 40 over 4. So this will be 9/4, so 49/4, which is about, let's see, 12 and, let's see, 4 goes into there once, 4 goes in there twice, 12.25, so we'll be up, so here's 11, 12, 13, so somewhere right up around here. So we've got a decent picture of our quadratic equation. Okay, so now let's answer some questions. So, based on our graph we did, what information about the graph is provided by x equals negative b over 2a plus or minus the square root of b squared minus 4ac over 2a? Well, hopefully you saw that those are your x-intercepts. What information is provided by the negative b over 2a? That is your axis of symmetry. And then what is provided by the square root of b squared minus 4ac all over 2a? Well, let's look back at our graph and our function. So if we look at that, that is our square root of 49 over 2. So that's 7 over 2. So what is 7 over 2? The 7 over 2, which 7 halves is, what, 3.5? That is actually our distance to our axis of symmetry. Half, 1, 2, 3. So that is our distance from x-intercepts to the axis of symmetry. Now, next up, we're going to get some practice using the quadratic formula. Alright guys, so let's take a minute to go through 2 examples together of just using and practicing the quadratic formula, then I'll let you guys practice on your own. So, first things first, we need to get this into standard form, so I'm going to subtract the x and the 3 over. So I'll have x squared minus x minus 3 equals 0, and now I can apply the quadratic formula. So our a is 1, our b is negative 1, and our c is negative 3. So I'm going to substitute those values in. So x equals negative b, which is negative 1, which is positive 1, plus or minus the square root of our b squared, minus 4 times our a value times our c value, all over 2a. So 2 times 1. Now I need to simplify. So I'm going to have 1 plus or minus the square root of 1 minus, let's see, negative 3 times 1 is negative 3, times 4 is negative 12, all over 2. 1 minus negative 12 is really just 13. So I have 1 plus or minus the square root of 13 over 2. And that's it. There are your 2 answers right there. All right, let's do one more. Let's look at number 7. So once again, we need to write it in standard form. So I'm going to subtract my 14x over. And I have 2x squared minus 14x plus 23 is equal to 0. So now my a is 2, my b is negative 14, and my c is 23. So now I'm going to solve. So I have my opposite, my b value, which is positive 14, plus or minus the square root of negative 14 squared minus 4 times a times our c value, all divided by 2 times our a, which is 2. And I need to simplify. So I'll have 14 plus or minus the c, negative 14 squared is 196. See, 2 times 23 is 46. 46 times 4 is 184. All divided by 4. All right, 196 minus 184 is 12, so I have 14 plus or minus the square root of 12 divided by 4. Well, this square root of 12 can be simplified, and it can be written as 14 plus or minus, let's see, 4 is a perfect square, and it's in there, so it'll be 2 times the square root of 3 all over 4. Now, each of these can be reduced by 2, so our answer will be 7 plus or minus the square root of 3 divided by 2. And there's our two answers. So go ahead and pause the video and complete number 8, 9, 10, and 11. Okay guys, go ahead and pause the video if you need to check your answers. Here they are. And let's look at another type. So in this next section, we're going to be using the quadratic formula to check each of the following claims about the equations and solutions. So it says that our solutions are x squared plus 5x minus 6 equals 0. It says the solutions are integers 6 and negative 1. All right, so let's use the quadratic formula and check. So we'll have x is equal to opposite are b plus or minus the square root of b squared, which is going to be 25 minus 4 times a times c, all over 2a. Which is going to be negative 5 plus or minus the square root of 25 plus 24 all over 2. So negative 5 plus or minus the square root of 49 all over 2. So yeah, it looks like, oops, square root of 49 is 7. We're going to at least have integers, and let's see if they're the correct integers. So negative 5 plus 7 is 2, divided by 2 is equal to positive 1. And negative 5 minus 7 is going to be negative 12 divided by 2 is negative 16. Negative 6. So it looks like we have integers are correct, but that the integers 6 and negative 1 are incorrect. So go ahead and take a minute and pause the video and do B, C, and D. Alright guys, go ahead and pause for a minute if you need to check your answers, okay? Hopefully what you guys started to see is that this thing underneath this square root is going to help us to see what type of solution we have. The expression underneath the square root actually has a special name. It's called the discriminant. And we will talk more about our discriminant later. So basically, just for now, let's talk about it in general. So the discriminant is the b squared minus the 4ac. And this will help us decide if we have a real solution, if we have imaginary solutions, and so on and so forth. So, for instance, if we look at this quadratic equation right here, x squared minus 6x plus 13 equals 0, this is the answer that we end up getting when we use the quadratic formula. As you can see here, we're going to get an imaginary number, okay? So, let's sketch this and let's just make sure that we're good on the connection of what's happening. So our answer here, when we simplify this, is 6 plus or minus 4i divided by 2, which would then simplify to 3 plus or minus 2i once we simplify that 2i. So this is a complex solution, so let's see what that means graphically. We briefly hit on this yesterday, but let's just make sure it's a connection, okay? So let's sketch this graph. For me, I'm going to sketch it as if I'm going to put it in vertex form. So I'm going to complete the square. So I'll have x squared minus 6. X is equal to negative 13. I'm going to have my 6x. Half of my 6x is 3. 3 squared is 9, so I'm going to add 9 to both sides. So this guy will factor to, I'm going to write it right down here, x minus 3 squared is equal to negative 4 plus y. I'm going to add my 4 over, and I get x minus 3 squared is equal to, x minus 3 squared plus 4 is equal to y. So my vertex is 3, 4. There's no a value, so I'm just going to have my normal pattern. So left and right, 1 up 1, over 2 up 4. And that's enough points to see. Okay, so how does the graph show that there are no real solutions? Well, look, it doesn't hit the x-axis, so there are no x-intercepts. So write the solutions to the quadratic equation using complex number. This is what we did up here. So it is just our lovely 3 plus or minus 2i. All right, so what I need you guys to do for homework is please solve A, B, C, and D using the quadratic formula, and you should be getting complex numbers. So we've already been doing it, so you're going to be writing it with I. Good luck, and I'll see you guys tomorrow. Your homework, remember these 4.